All right, we've already talked about the zeros of the function and the leading coefficient test. Now we're ready to graph the function. So these are the steps that we will follow. So if you want to go ahead and just pause and read them, I'm going to have them all listed out as steps. So step one is we're going to identify the end behavior using our leading coefficient test. So our degree is 4 and our leading coefficient is greater than 0. So if we go up to our chart, our degree is even and our leading coefficient is positive. So that's telling us that we're going to rise on the right and the left. Then we're going to find the X-intercepts, which will be the zeros of the function. So we're going to set the function equal to 0. And we're going to factor it. This is a quartic function, and it's a trinomial. So we say, what are the factors of 1 that add to -2? Well, that would be -1 and -1. We also need to split up that first term. That's an x to the 4th. So we're going to split it up as x squared and x squared, and then -1 and -1. And then we're going to use the difference of two squareds and factor as x minus 1, x plus 1, x minus 1, x plus 1. Well, notice that these two are alike, so that's going to be a multiplicity of 2. So when I solve it for x, I have 2 of those factors, so that's a multiplicity of 2. Same thing with the next two parentheses. There's 2 of them. So when I solve it for x, we get -1, multiplicity of 2. So when we go back up to that chart in the yellow, when it's even, it's going to touch the x-axis and turn back around or bounce. So we need to keep that. So both of these are going to they're going to bounce off the x-axis. All right, let's find the y-intercept. So to find the y-intercept, we're going to set the x's for 0. So we're evaluating the function for 0. So you can evaluate the original function or the factored function. It doesn't matter. So I'm just going to go ahead and use this original function. And evaluate it for 0. And we get 1. So the y-intercept is going to be over 0, up 1. I do also need to identify those x-intercepts as ordered pairs. So this is over 1, up 0, and -1, up 0. Use possible symmetry to help you graph. We're going to bypass that for right now. Use the fact that the maximum number of turning points is n-1. We're going to skip that, and we're going to move on to just graphing it. So when we graph this function, we want to identify the x-intercepts and that y-intercept. So I'm going to have 1, 2, and 3, 1, 2, and 3, -1, -2, -3. Okay, so now we're going to go ahead and graph those intercepts. So y-intercept of 1, x-intercepts at 1 and -1. So there's my y-intercept. Here's my x-intercept. There's my other x-intercept. Remembering your end behavior. Your end behavior was rising on the right and rising on the left. So you go to the end x-intercepts. We're rising here. Come on, it's not letting me right here. And then it's rising here. All right. Then remember, on these x-intercepts that are repeated, they're going to bounce off. And then continue on and bounce off. And that will be the shape of our graph. We nickname that the shape of a W. So we don't need to work with step 4 and 5. Find the relative maximum or minimum. This point here is the relative maximum over 0 up 1. These 2 points are called the relative minimums.